Over centuries, we've been taught that our hair gives us a certain personality and charm. But if you've ever dyed your hair, you've more than likely been disappointed in the results at some point. Then you face the panic of actually fixing it. I heard about a company that can answer these questions before you face them. But can they really find the best solution for something as personal as hair color, using something as technical as AI? I'm Arjun Dutt from NVIDIA, and this is I Am AI.
So as soon as a user will open the application onto their iOS device, and they're instantly able to see their live image. It's like looking in a camera feed, so as you're moving back and forth, we're seeing that you're moving. It's like looking into a mirror. And based on that, we can instantly start tracking your face, tracking the hair, and you can apply any color you want. We've been around for over a decade now, and it all initially started back when our CEO, who is also the founder, Dr. Parma Rabi, was working on face tracking and lip detection. Some of our initial clients, Allergan being the very first one to ever launch with us, had approached him with the concept and idea of, can you take this facial tracking and do it in a different way and actually show what a product could look like for things such as Botox and Juvederm injectables. But we've progressed so much over time because there's such a need in the market for the consumers to see what they could look like with a hair color applied before buying that product and doing it themselves or going to the salon. And so being able to utilize that, it is so easy to use now. There's no user input. You just look at a screen, and even at the back of my head, without my face necessarily being shown on the screen, we can track that. We know where your hair is. We know what the texture really is. We're understanding the placements, and we can color it virtually, anything you'd like.
As facial tracking and lip detection have become more common uses of AI, what was the natural progression from face to hair? Where does the process start?
The initial applications were 2D applications, where you would upload a photo. You had to manually outline your hair or make corrections to what the detected mask was, and then you would see a coloration result on that 2D photo. But it doesn't give you that live view. And so what we had to do was really understand how can you take all of the data and know-how we have about hair and apply it to understanding and finding 3D hair. So in image, find every strand of hair and know what is hair that's black, but what is not hair that also is black but is part of the background.
There are 150,000 hair follicles that are unique to every human. I wondered where you even start the training. How can you teach a network to look at each strand of hair?
What we had to do is manually annotate these images. So we had to make sure our users would go and manually define what is hair and what is not hair to provide training data for the neural nets. And the neural net was trying to mimic what humans could do. So that first attempt did well, but it wasn't perfect. So we had to actually improve our neural net architecture.
MODIFACE uses a convolutional neural network, or CNN, that's been modified to generate a mask for the hair in an image. Typical CNN architectures consist of a sequence of convolutional layers of increasing depth and decreasing resolution. Together, these layers are called a convolutional encoder. They provide strong feature maps in deeper levels of the network, but without all the detail of the source image. To generate a reasonable mask for hair, this process has to be reversed. This is done by decoding the feature maps generated by the encoder using upsampling and convolution to improve resolution. This encoder-decoder model forms a fully convolutional network, or FCN, that can generate a detailed mask for hair.
It's interesting that once this neural net understands what hair is in one image, when you provide it live video, it can build that three-dimensional model of the video. But the basic ingredient of what it detects is a 2D hair image.
The hair color app is so easy to download and try out, I wanted to take it out in the world. I wanted to see how people responded to it. I was curious to see how hair color enthusiasts would react, as well as those who would never risk dyeing their hair.
No, there it is.
Whoa!
So the hair color app is a demo of what our technology can do. Eventually, customers can use this technology if they go in salons, if they're trying to get on a website, if they're trying to buy a hair color product, or if they're just at home, they're wondering what color might be best for them. So there was a lot of hope and a lot of guessing. But now it's all about knowing precisely what the color will look like on you in different lighting conditions, and by the time you commit that this is the color you want, you know it is the one you really do want.
After seeing how people responded to the app, I wanted to know how this technology could evolve. What about this is going to be the game changer in the beauty industry?
In terms of where this is going to be going in the future, I mean, AI is really just hitting the market. And I think in the future, this is going to be more prominent in new locations, but it's also going to be used more for that personalization. Consumers to understand what's going to work best for them, not what works best on that celebrity in the magazine or what works best on that model, but it's all about them, their face, their skin tone, their hair colors, like what works for who they are.